we're all on the same page. Okay, I'm looking for volunteers for the math workshop. Anyone want to volunteer for number 4? Yes, table 2.
H squared minus 49 for number 4.
Okay, thank you, and you can have a point. As discussed yesterday, we're foiling first, outer, inner, last. We're so good now that unless we really need to draw on the arrows, we're not going to draw on the arrows. And we understand that outer and inner tend to combine. So in our head, we did h squared minus 7h plus 7h. So the outer and the inner canceled each other out. And then last we have minus 49. If you need to write it, you can. But I love how Arturo just gave me that final answer. Okay, I'm going to ask for someone else for number 5. You know that. Okay, yes, table 1.
Y squared minus 1.
It is y squared minus 1. Again, the outer and inner end up canceling out. Positive 1y, negative 1y, they end up canceling out. And you can have a point for that. Are there any questions on 4 or 5? Okay, so FOIL was review. 6, 7, and 8 are straight from what we talked about yesterday. Function or not a function. Will asked a good question a few minutes ago. Do you have to list the domain and range? No, you actually do not with these. And you don't have to say one-to-one onto neither or both. We'll discuss that again momentarily. Let's see, table 1, function for number 1, he says. That is correct because each x value has only one y value, so that sounds correct to me. And you can have a point for that. Table 3, number 7. Why? Okay, because of the what? The 3's. Okay, you can have a point for not a function. Can someone fix why it's not a function? Yes, table 4? You had a thought? Okay.
No.
Yes, table 1?
The 8's go to 2 and 3.
Okay, our issue was with that input having 2 outputs. Yes, you can have a point for that. So 8 going to 2 and 8 going to 3 is an issue. What Paige pointed, it was a Paige or Day. What Paige pointed out is technically something else that we talked about yesterday. For a point, what was that thing we talked about yesterday? Paige said the issue was with the 3's being repeated. There was a term for that yesterday. It's not function, not a function. The issue of it not being a function has to do with the 8's. But it's got to do with something else. It's either going to be one-to-one, onto, neither or both. Pick one of the words. Yes, dear? What did onto mean?
One-to-one. Bro, hold up, bro. Nah, that don't count. I was just saying, you can't do that. You can't steal my shine.
But why would it be onto?
Because, like, it's connected to one thing. One number's connected to,
Okay, but you heard yourself. One number connected to one thing. You just described 1, 2, 1. So I'm gonna withhold that point. Although you were very fast, table 4. If you can be that fast again, you're gonna get you some points. So it's not one-to-one either. But since it's not a function, we don't even have to look into stuff like that. So Ms. Compton's just kidding around, I guess. And then number 8, function, not a function. Let's see, table 4. It is a function. Natalie's good. I was trying to spread the wealth. My gosh. Can't have all the points. Okay, as for our notes yesterday, remind me, what is 16 squared? 16 squared? 256. 12 squared? 13 squared? 169. 14 squared? 15 squared? 16 squared? Oh man, it's gonna crash and burn today, people. Crash and burn. There is a practice quiz today on 1 through 16. The real one we moved to Friday, but I hate to burst your bubble. Today is Tuesday and it's not getting any better, so you're not practicing. What are you doing with your life? Okay, we'll get to that. Just keep that in mind. Okay, so I need to correct something. Can you believe it? I'm not perfect. Yesterday I told you I was having a blonde day and couldn't remember what to put in that very first blank. A blank is a set of ordered pairs. I know the right term now. Duh, Miss Compton, read the directions. Our title for this section is Relations and Functions. Why would we not put the word relation as one of the vocab things? a relation. So I need you to fix our blank from the other day. A relation is a set of ordered pairs. That was the vocab term we were looking for. Okay, I think you got domain and range, function, not a function. Just a reminder, one-to-one, we were talking about every input is going to only one output, meaning one is going to D, so nobody else can go to D. Only one is going to D. And then onto, I think is even easier to spot. It says everybody in the range have a match. This function would not be onto because C doesn't have a match. And then one-to-one and onto, we've got all these pairs. Everybody has, it's like all the pairs going to Noah's Ark or something. Everybody has a match and only one match. Okay, so that's what we were talking about yesterday, function, not a function. And we talked about the vertical line test, which your teacher may have called the pencil test. And then we talked about evaluating a function. In fact, if it said they wanted to know F at cupcake, my answer would seriously be 3 cupcake minus 5. Whatever is inside that parentheses, you replace the X with whatever that is, even if it's something silly like cupcake. It's never going to be cupcake, but I wish it was. Okay, last night I asked you to do 4 problems. I'm not going to check it this exact second. I'm not. Hopefully Seth will get it together and have it done by the end of class. And show, I know. And then he'll show me those then. We're going to move on now. So you were supposed to do 5, 6, 7, and 8 for homework. If you didn't, I swear after the checkpoint in the quiz, you should have a few minutes. Okay. Now we're moving on. Yep. All the things today. The checkpoint is on that. One-to-one, onto, is a function, not a function. How can you evaluate? Now, we're moving on to the next section, and I should probably tell you words that you're not going to want to hear, because you're like, we just took a test. You know, we move fast in Algebra 2 Treg. There is going to be a quiz on 2-1 and 2-2 on Thursday. Today is Tuesday. You got 2 days notice. That was nice of me. Didn't have to give me notice for a quiz. So there is a quiz on 2-1 and 2-2 on Thursday. So hopefully you've got 2-1 down. Now we've got to figure out 2-2. So it starts off with relations that have straight line graphs are called linear functions. Relations that are not linear are called, anyone know if you're not linear, you're called this? Non-linear. Table 1 gets a point. They're called nonlinear relations. An equation such as x plus y equals 5 is called a linear equation. A linear equation Miss Compton spelled today, has no operations other than addition, subtraction, and multiplication of a variable by a constant. The variables may not be multiplied together or appear in a denominator. So, for instance, you would tell me 1 over x times y. That doesn't look like a linear function. What slope is that? Where do you put the intercept? We don't know how to graph that. We also wouldn't know how to do 2xy. How do you... That's not linear. Okay, a linear equation does not contain variables with exponents other than 1. And the graph of a linear equation is always a... The graph of is always a Kelsey with a U. You can have your point. It's always a line. Okay, and then Miss Compton's in a hurry, so she's going to skip the review because that's where it was in all the words. And we're about to practice anyway. So we get down here and it says an example of a linear equation. Notice that the x and y, they're not multiplied together. They're not divided by each other. They each have an exponent of 1. This one is not a linear equation. It's got an exponent of 2 with the y. This one's not. It's got the square root of x. This one's not y. Why is this third one on the list? Why is it not a linear equation? Yes, Paige. You said it first. Because it's got x and y. And then the fourth one, Why is it not a linear equation? Table 3 again. Divided by x. That's a problem. Okay, so a linear function is a function with ordered pairs that satisfy a linear equation. So first, we're just going to identify. That's what our top learning target says anyway. I can identify a linear function. So we're just going to say, is it linear? Yes, no. And if it's not, we're going to explain why. Let's go to our first one. It's 6y minus x equals 7. Is that a linear function?
Yes.
I hear a yes, so every group can get a point. If Mackenzie's lying to me, she really doesn't understand, she can always rearrange this equation and put it into y equals mx plus b to prove to herself this is a linear equation. Okay, we get to number 2. Yes, dear. Tell me why. Well, f of x is the same thing as y. So it could say y equals 2 over x plus 6 if that's what you're mad at. And that's what we should say. No. And I'm going to just put due to the fraction. But you could say because we divided by x plus 6, however you want to write that. Okay, and then let's go to the next page. Number 3, is this linear? I heard no, if you can explain why. Say it again, Mia. No, and it's because of the x and y being multiplied together. Yeah, Will says a lot of things. We're going to save him for when we need him. Oh, and then we get to a tricky one. A real tricky one. Number 4. Yes, dear.
No.
Yes.
Why? It's still a line. So if you had to write it in y equals mx plus b, it would be y equals 0x plus 19. The slope is 0. It's just a solid straight line at 19. So if we were to graph it, it would be a line like the way I'm holding my arm right now. Just a straight line at 19. I don't know why I put a comma. It's just yes. Maybe it should be an exclamation point. Okay, and now we get to another tricky one. Number 5. I heard yes, but I also heard no, and they're both in question form, which is kind of
Yes.
why.
Because it's not divided. Like the 3x fraction is not divided.
Okay, yes. So I want to help him clarify a little. The fraction's okay because why?
It makes it a VX switch around.
Say it again.
It makes it a VX switch around.
Lord, this is why we save you, and you can have a point now.
So we can have fun. Alright, cool.
Yes. Okay. Isn't it okay to have a fraction slope? Isn't it okay? So what Will said is really right now we had y equals 8 minus 3/4 x. He's saying the b and the mx are switched around. So if we were to swap them back to normal, it would be y equals negative 3/4 x plus 8. And Braxton knows how to graph that line. He knows to put his intercept at 8. He knows how to count the slope negative 3/4. So if you were going to think and know, it's okay if the numbers are a fraction, but it's not okay if x and y are involved in the fraction. The way on our earlier example, number 2, x was actually in the denominator, and that was a problem. Okay, and then we get to number 6. No, table 6 says y. And then I like that. So it's no, and I'm just gonna put due to the exponent. We just discussed with a linear function, the exponents for both the y and the x have to be 1. And you really knew all that. And then, if we're going to make life even more complicated, We did some but math workshops. Words weren't coming. We did some math workshops the other day with standard form. That's the first blank. Standard. Remember, you kind of broke my heart and we discussed that it was okay that you had forgotten for now. Well, now it's no longer okay because we're going over it, which means it's going to be on the quiz. Okay, standard form is ax plus by equals c. A, b, and c are integers with a greatest common factor of 1. Okay, so the first thing we probably need to do is rearrange our equation so it looks like ax, by, c. So I need to move that 4y over. So I'm going to have 2x minus 4y equals negative 1. If you need to actually show yourself the step where we subtracted 4y from both sides, you can. If we do this, my a is 2, my b is negative 4, and my c is negative 1. Are there any questions about that? Okay, well then I need help on number 2. Can someone help me rearrange the equation and tell me the a, b, and c?
2x to both sides.
Okay, so I have negative 2x plus 5y equals 3. Now what?
Now you do the A.
And what do you think a is right now? Okay, we discussed this the other day. Are we allowed to have a negative with that a?
No.
We're very, very picky about that a. It needs to be a pretty number. So we're going to have to get rid of that negative 2. So we're going to have to multiply everybody by negative 1 and have 2x minus 5y equals negative 3. There are picky rules for stuff in standard form. The a has to be a pretty non-negative number. So now, Seth, what is my a, b, and c?
A is 2, B is negative 5, A is C.
Perfect, and you can have a point. Okay, I'm going to leave number 3 for you to deal with. And let's go on to number 4. Why am I not going to leave number 4 for you? I feel sorry for you with the fraction. So, what could I do to help myself get rid of all these? I don't want to deal with these fractions today. And I don't want decimals. I'm not changing it to 0.75 and 0.6666. I just can't. Very devilish. What could I multiply everybody by to get rid of that for those fractions?
2.
Yes, Kelsey, you can have a point. So if we multiply everybody by 12, those denominators are going to end up going away. So if you need to actually show yourself distributed, you can. So we would have 36 over 4y equals 24 over 3x plus 60. But hey, if we were smart enough to do these reductions in our head, we could. You don't have to write that purple line. If you can do some math in your head, that's fine. It reduces to what? Yes, dear? You can have a point for that. And then, but we're still not happy because it's not in standard form, so help me move it to standard form. Negative 8x plus 9y equals 60. And then, oh no, we've got to multiply everybody by negative 1. And if we had realized this was going to happen, could we go back in time and multiply everybody by negative 12 to alleviate this problem? We could have, but I didn't anticipate it. So 8x minus 9y equals negative 60. So my A is 8. B is negative 9. And C is negative 60. Again, maybe Kelsey was smart enough in her head to realize when I move that x over, it's going to be negative. So maybe in my very first step, instead of multiplying everybody by 12, I could have multiplied everybody by negative 12 and saved myself those last 2 steps. But I was not that smart this morning. Okay, I'm going to leave number 6 for you, but we will do number 5. Why do I need to help you with number 5? And every group can have a point for that. There is no x. Does that mean we can't do this? Yes, dear.
That rule for like A, you don't have a negative. Does that only apply for A?
Yes, so, and if you want to make a note to yourself, A can't be negative or a fraction. So really, if you remember, which most people, to be honest, still messing up classifying numbers, good thing we're letting it go now. So really what we're saying is A is a natural number. You need to make sure that A is a natural number. But if you're not sure about naturals, because there's some people in the room who just still don't have that down, just remind yourself, can't be negative, can't be a fraction. A needs to be a pretty number. Okay, so back to 5. That was a great question, Hunter. You can have a point for that. Back to number 5. I don't have any x's, but I need to put it in standard form anyway. What would standard form look like? Okay, if I add 9 to both sides, I would have 5y equals 9. I give you that. But what about the x's? So I'm going to put 0x plus 5y equals 9. Just write it from my own knowledge. Do you have to do that? I don't know. It helps me identify A as 0, B as 5, C as 9. I'm afraid if Addison doesn't put the 0x, or at least think about it in her head, she's going to be very tempted to put that A is 1. So I would put it as 0. Oh, what if you put 0? What? Say it again. A is x. And there were no x's. So A is 0. Okay. So if there are no y's, B would be 0. And if there were no c's, C would be 0. Okay. And then let's move on. We got one last page, and that's where we're going to, Ms. Compton will stop talking math at you. And look, you only, at the moment, you only have 2 problems you have to do yourself today. Woohoo. One last page. And I got my people packing up. We're doing the one last page. Chill out. Okay, so we can graph an equation using just the x and the y intercept. We don't actually, normally, if Valeria saw this problem, I know what she would do. She would put her point at A. She would count down 4 over 1, down 4 over 1, and graph it like usual. Not a bad idea when stuff is in y equals mx plus b. But if you look at number 2 and number 3, we're not in that form anymore. So I get what Valeria was going to do, but let's talk about other ways Valeria can graph. What is the y-intercept of this equation? Oh, I'm on the wrong side, aren't I? I hate it when that. Bless you.
I was putting it safe.
I'm on page 7. Yeah, I hole punched them wrong. I knew what I did when I did it. I've hole punched yours wrong. I'm sorry. I'm only so perfect. It's on the back of the next page. My bad for having one page backwards. You knew when I handed you 20 pieces of paper at once, something was not going to be quite right. Mia's like, I've got to re-hole punch and make it proper. Okay, my bad. Thank you, Paige. I'm just going to let it go being backwards. I'm that good. My bad. Okay, so we can graph our graph using the x-intercept and the y-intercept. To find the x-intercept, you plug in 0 for y, because an x-intercept happens when y is 0, so why not just plug in a 0? And to find the y-intercept, you plug in a 0 for x. So basically, whatever variable you're looking for, you want the y-intercept, plug in a 0 for the other variable. So back to number 1, if we had plugged in a 0 for x, of course it makes sense that that y-intercept is 8. So if you plug in a 0 for y, what is the x-intercept? If you plug in a 0 for y, what is the x-intercept? Yeah, does it count when I've done 74% of it then?
I'll say it before you wrote it down.
True, you can have the point. Okay, so again, we want, and I get that Valeria could have graphed this equation a little faster than my math over here. I get that. But hopefully she's smart enough she can do a lot of this in her head. Because let's face it, when I thought through that 0, I moved the 8 over in my head. I divided by -4 in my head. I knew it was 2. I showed it on my paper to show you, but I can kind of do that in my head anyway. So I've learned my 2 intercepts. I have an intercept at x equals 2. I also have an intercept at y equals 8, which is almost off the page. And then if I'm not very good at connecting dots, hopefully you're going to use your notebook or something to try to do so. If I connect the dots, hey, I've got my line. We're going to use this same logic on number 2. So I need you to plug in a 0 for x and tell me what the y-intercept is. What is the y-intercept?
3.
When you plug in a 0 for x, what is the y-intercept? 4. Again, and it's really easy when it's in standard form because you just cover up the piece you don't need. So 3y equals 12. So I have y equals 4. So the y-intercept is at 4. And then the x-intercept, I'm going to do the opposite. I cover up the y piece, and I have 2x equals 12, so x equals 6. And then you really don't have to write anything. And I just go graph those 2 points. I've got a point at 6. My x-intercept's at 6. My y-intercept is at 4. I do my best to connect those dots as pretty as I can. And I call it a day. Yes, dear. I will leave number 3 for you to deal with. So you only have 3 stinking problems to deal with tonight. If you did not do well in the last test and you're looking for extra practice, you know you were given this whole workbook, right? No one ever said you couldn't work extra problems. You can work it, come see me, I would check it. It could be great. Okay, you can go ahead